Welcome to the biological functions lesson. Through this activity, you will learn what a biological function is, you will learn how nature is multifunctional, and you will also learn how functions are a crucial step in biomimicry in translating what nature does into our designs. But before we dive into the content, we would really like to just introduce ourselves really quickly. My name is Michelle, and I'm really excited to work with you through these biological functions.
Thank you, Michelle, and hello all. It's my privilege to be here today and guide you through biological functions.
Okay, let's talk functions. So in general, a function is a requirement that a design has to achieve in order to be successful. It also is very specific to where it lives. So the context and the user is an important component of a function. And a function is a verb, so it's not a noun, and that is one of the most important things to take away. Now, in biomimicry, we need functions in order to translate what nature does into our systems and in a correct way. So in order for us to find solutions to our problems, we have to define the specific function we would like to solve for in order to go out and ask nature, how do you do it? This searching for the function also helps in translating biology into design or design into biology. So in biomimicry, we call this the function bridge. And it really just allows people from different disciplines to speak the same language and to understand each other so that a designer can talk to a biologist and vice versa. So let's talk about functions that people are familiar with already in their daily life. For example, the functions of a shoe. Now, if we were to go out to nature and ask nature, how do you design a shoe? You might not find too many organisms that will give you some clues on how to do that. But if you were to ask nature, how do you cushion, or how do you support and protect, and how do you visually signal, you might be able to find some really ingenious ideas.
Like our shoe, organisms have requirements they must meet in order to survive in their particular environments. These are called biological functions. They are driven by the biotic or living and abiotic or non-living forces around them. Predation, reproduction, generating energy, living in an Arctic or living in a desert are all examples of the forces that drive biological functions. As Michelle noted, functions act as a bridge between the human design and the biological design. Equally important, though, function is also a gateway to a deeper understanding of the biology. While boiling an organism down to a list of functions may seem reductionist, it is often the first step in unlocking and understanding nature's genius. This is where the splendor resides in nature. After we identify an organism's functions, we can then start asking how and why. How do we take that first step then? How do we identify biological functions? It's actually easier than you might think. It starts with quieting the human mind. Sit in nature and just observe and ask good questions. Observe the organism itself, but also its environment. Observe the other organisms in its environment. All organisms must make energy, reproduce, keep from being eaten. Think about these and other core requirements in the context of that organism's environment. Then just start asking questions. Those questions can be structured in ways to help you tease out functions. A function will fit into a sentence that starts with, how would nature? For example, how would nature keep cool in the desert? Functions can also always be expressed as a clause starting with a verb. In this example, the biological function would be keep cool in the desert. This can be taken a step further though, as the real survival requirement is not necessarily keeping cool. Rather, the organism needs to thermoregulate to survive in the desert. So this could be rewritten as, how does nature thermoregulate in the desert? Let's look again at the functions that a shoe performs and think of the organisms that perform these functions. Let's also look at the environment and the factors in the environment that drive these functions.
Just as our athletic shoe had to cushion the foot, ankle, or other joints of a person, due to their enormous size, elephants must cushion their footfalls or risk not being able to walk. The athletic shoe had to provide structural support for the foot or ankle. Here we have an example of a bioweaver bird, which creates a nest that hangs from a tree. It must provide structure and support not only for the eggs inside and the adult birds when they're inside, but the outside of the nest also provides structural support for when the adult birds are climbing on top of the nest. The athletic shoe can shield the foot from liquids like water. In nature, we have a fascinating example of a diving bell spider. This is a spider that has no gills, yet can spend almost its entire lifetime underwater. And so, to survive in its environment, it has to have a waterproof pocket in order to breathe. These lizards also signal just like our shoe. Unlike our shoe, though, they must be able to turn their signals on and off or risk being eaten.
So now it's your turn. We're asking you to go outside in your backyard, in a zoo, a botanical garden, a natural history museum, and then find a spot where you can sit down and be calm and quiet your human mind for a little bit. And we're asking you to just observe nature in a certain way to look for functions. Now, on the resource page on naturefactor.com, you will find a worksheet. This worksheet has 2 pages. On the front, you're asked to find 4 different organisms for one function listed. And on the second page, you will find 4 functions for one organism. So go outside and have some fun with this, and then come back for part 2.